Have you ever wondered how the law of conservation of energy applies to motion? To unravel this mystery, we will delve into some intriguing problems and their solutions today. Let's start with a simple problem. Imagine a skateboarder gliding down a half pipe. The skater begins at the top of the pipe with a certain amount of potential energy due to his height, which then transforms into kinetic energy as he descends. By the time he reaches the bottom, all his potential energy has converted into kinetic energy. This is a classic example of the conservation of energy, where the total energy remains constant, just changing forms. Now let's take a step further and consider a scenario where the skateboarder is now performing a trick, such as a jump. When he jumps, he gains potential energy. As he descends back to the ground, this potential energy converts back into kinetic energy. Even in this more complex situation, the law of conservation of energy still holds true. Moving on to a more challenging problem, consider a bullet being fired from a gun. When the trigger is pulled, the bullet gains a tremendous amount of kinetic energy, which it retains until it hits its target and comes to a stop. At this point, all the kinetic energy is converted into heat and sound energy. Again, the total energy remains constant, just changing forms. Finally, let's tackle an even more complex problem. Consider a satellite orbiting the Earth. The satellite has both kinetic and potential energy. As it moves closer to Earth, its potential energy decreases while its kinetic energy increases, and vice versa. Despite these continual changes, the total energy of the satellite remains constant, demonstrating yet again the law of conservation of energy. In summary, whether we're looking at a skateboarder in a half-pipe, a bullet being fired from a gun, or a satellite orbiting the Earth, the law of conservation of energy is always at play. Energy doesn't disappear, it merely changes forms, from potential to kinetic and back again, or into other forms like heat and sound. Remember, the total energy in any system remains constant, so the next time you see a skateboarder gliding down a half-pipe, a bullet being fired from a gun, or even when you think about satellites orbiting Earth, remember the principle of conservation of energy. It's not just a law of physics, but a fundamental aspect of our universe.